Hi, I'm Nick from First Tech Challenge Team 15772 Brady Goats. In this video, I'm going to discuss our shooter prototype for the Ultimate Goal season. When the game was first released, our team brainstormed and compared over 10 potential shooter designs. After discussing the advantages and disadvantages of each, we decided to prototype three designs: a one-wheeled straight shooter, a 90-degree shooter, and a 180-degree shooter. Our goal was to make one prototype that could be configured to test all three designs. Another goal that our team had when designing the shooter prototype was to only use parts available in our workshop so that we would not need to buy parts. Our plan was to use a 4-inch blue stealth wheel from AndyMark, two AndyMark Never-Rest Orbital 3.7:1 motors, go-build bearings, collars, shafts, and custom CNC parts. From this plan, we began our design. Now I am going to discuss the design of our shooter prototype. There are two main parts to the design: the gearbox design and the shooter itself. The gearbox contains two AndyMark motors that have a free speed of 1,780 RPM, and there is a gear mounted to each motor. These gears are from Tetrix and have 120 teeth. The middle shaft has a 40-tooth Tetrix gear mounted to it, and this 3-to-1 ratio causes the output shaft to rotate around 5,340 rotations per minute. The gearbox is held together by two CNC plates made of Baltic birch plywood. We attempted to allow for a 4-to-1 gear ratio, but there was a mistake made in the calculations, so the middle gear did not fit. The main part of the shooter prototype is mounted to the top of the gearbox. The two main plates are made out of PVC sheet, a durable material that we have used in the past. There are a total of 8 standoff holes in each plate, allowing for better stability. Depending on the configuration that we are testing, we have to move the standoffs to different holes so that the rings do not hit them. The last major piece of our shooter prototype is the wall that the ring rolls on. The wall can be easily configured for each type of shooter since there is a straight groove tangent to the semicircle. This picture shows the 180-degree wall configuration. This picture shows the 90-degree wall configuration, and this picture shows the straight wall configuration. The wall is made of acrylic, and we added one extra layer of grippy bicycle tape to minimize ring slippage and maximize consistency for the 90-degree and 180-degree configurations. For the straight shooter, however, we had to add more compression so the ring would be in contact with the wheel longer. The minimum distance from the wall to the shooter wheel is around 4.8 inches for the 180-degree and 90-degree configurations, and around 4.7 inches for the straight configuration. After finalizing the design, we assembled the shooter. We documented our results in this spreadsheet. For each configuration, we tested the prototype for max distance from the back wall of the field and from the launch line. The angle of the shooter was determined by the angle needed to be launched into the high goal. These numbers are the distance in inches that the ring hit from the ground. The range is the minimum vertical distance subtracted from the maximum vertical distance. Lastly, distance is the approximate horizontal distance that the ring traveled when it hit the ground or the wall. Once we had recorded this data, our team analyzed it to compare the three designs. As you can see, the 180-degree shooter launched rings around 3 feet farther than the 90-degree shooter, which shot rings around 5 feet farther than the straight shooter on average. As expected, the range for the 180-degree shooter and the 90-degree shooter from the wall was more than the range of these shooters from the launch line. However, these numbers are fairly similar for each configuration from a given distance. Our biggest takeaways from this shooter prototype was that these three designs are very comparable, given that there were some sources of error. Another thing that I should mention is that our 180-degree and 90-degree shooter configurations were able to shoot over 16 feet, so we will have to limit this on our actual shooter. Even though our team will use our findings to develop our shooter design, we encourage all teams to design your own launching mechanisms based on your prototyping results and capabilities. After our team performed our testing, we brought the shooter inside and tested it on the actual goal. The first video shows the shooter launching rings from the launch line with the 180-degree configuration. The last ring seems to be deformed, and it is shown at the end of each video clip. This is the video of the 90-degree shooter configuration. Finally, this video shows the straight shooter. As you can see, the deformed ring does not go nearly as far as the other ones. Our team will have to consider this as the season progresses. I hope you enjoyed learning about our shooter prototype. To find out more about our team, please visit the links in the video description. Thanks for watching.